Good day, everyone. Last time we introduced quadratic equations and we said the emphasis was basically on the roots of quadratic equations. We said that an equation of the form ax squared plus bx plus c equals to 0, okay, where a, b, and c are integers, okay, and a not equal to 0, okay, is a quadratic equation. Quadratic. Oh, let me erase this. I don't know why I keep making mistakes. Okay. We said that this is a quadratic equation. That's part of what we discussed last time. We also looked at the various methods of finding the roots of quadratic equation, and we discussed the method of factorization. But the method of emphasis was completing squares, where we were able to come up with the, okay, x equals to a minus b plus or minus the square root of b squared minus 4ac, okay, all over 2a. We say that this formula can help us find the roots of any quadratic equation. If we know the value of, if we know what a is, what b is, and what c is, we just plug in and then get the x value. Those will be the roots of the quadratic equation, and there will always be two roots of the quadratic equation. Okay. The roots, the nature of the roots, nature of roots depends on b squared minus 4ac, okay? And this quantity, b squared minus 4ac, is what we call the discriminant. Discriminant, okay? Now, that dictates the nature of the roots or the x values we get when you plug in the value of a, b, and c, okay? If b squared minus 4ac, when you plug in the value of b and the value of a and c, and you get any answer which is more than 0, that is a positive answer, okay? This implies 2 real roots. Those are two x values, whether they are negative or positive, okay, one negative, one positive, or whichever, okay? Those are called the real values. Now, if b squared minus 4ac is equal to 0, okay, then it will mean that we have x is equal to minus b over 2a, okay? And when we get this scenario, then we say that these are repeated loops, okay? This implies repeated, okay? Repeated loops. That means that you get two x values which are exactly the same, okay? And if b squared minus 4ac is less than 0, okay? Less than 0, anything less than 0 is negative. So, you know, when you are computing the square root of a negative quantity, we cannot get it in the real plane, so we have to go to the complex plane, okay? And this would imply imaginary roots, okay? That's what basically we talked about last time. It's just a quick review of what we talked about, and we want to continue looking at roots of quadratic equations basically, but this was just, you know, a recap of what we covered last time. So in our discussion today, we want to discover how do we form quadratic equations if we are given the roots. All right. So if the roots of the quadratic equation are alpha and beta, then x equals to alpha and x is equal to beta. Okay, or you can say x minus alpha equals to 0 and x minus beta equals to 0. Now, these are called the factors of the quadratic equation. And when we get the two factors and multiply together, then we are going to get the quadratic equation. So, x minus alpha, if I multiply it by x minus beta, this will still be equal to 0 and to give my quadratic equation. So, I'll have x squared minus, okay, alpha plus beta into x plus alpha beta. This is equal to 0. When you go ahead and distribute these two brackets, we're going to get x squared minus alpha plus beta into x plus alpha beta equals to 0. And you would form a quadratic equation. So let's call this equation 1. Okay. And we know that any quadratic equation can be written as, we have any quadratic equation can be written as ax squared plus bx plus c equals to 0. And the a, b, c are integers, okay? They are numerical values, but for any quadratic equation, a must not be equal to 0. Okay, this fact must be fulfilled. Okay, you can change this equation and divide through by a, so you have x squared plus b over a of x plus c over a is equal to 0. Okay, remember last time we said that if you get the roots and add the two roots together, then you get minus b over a. And if you multiply your roots, alpha, beta, you end up with c over a. So we can change this and write it as the equation. You call this equation 2. Okay, 2 can be written in terms of 1. Okay, where we have x squared. We have x squared. Okay, minus the sum of roots plus the product is equal to 0. It's the same thing actually. So if we are given the roots of a quadratic equation and they want us to go ahead and write the quadratic equation, then equation 1 will always give us the equation in the most convenient form. Okay, so to just put it in words, x squared minus sum of roots times x plus product of roots is equal to 0. So let's see some examples, just quick examples, because this is just so easy. So we are looking at this example. What they want from us, they are saying write down the sum and the products of the roots of the following equations. So there are many, but the first one is 3x squared minus 2x minus 7 is equal to 0. It is simply write down, but because we are learning, I will explain it more. Okay, so let's look at the solution. If you want to compare this with the general quadratic equation, where we have ax squared plus bx plus c equals to 0, then you start my a is equal to 3, b is negative 2, and then c equals minus 7. Okay, and we know that the sum of roots is always a minus b over a, which is, get your b, minus 2, okay, minus of minus 2 will be a 2, divided by a, which is a 3, and then the product, okay, is simply c over a, and my c, what is it? It's negative 7 divided by a, which is a 3. So this is just a simple question. They want you to get used to writing sums and products, okay, forming the quadratic equations given sums and products. So we begin with something very simple, okay, and then we test our understanding with what we may think is hard, though there is no question which is hard. it. They are just technical questions. So just simply writing down, okay? What is B? Let's look at B. B is 5x squared plus 11x plus 3 equals to 0. Okay, so they want you to go ahead and write the sum and the product of roots of 5x squared plus 11x plus 3 equals to 0. So what do we do? Do the same. So since we are looking at a quadratic equation, you always write down the general quadratic equation, which is ax squared plus bx plus c equals to 0. Compare the given equation with the general quadratic equation. You discover a will be equal to 5, b equals to 11, and then c equal to 3. And note the sum of roots, okay, will always be minus b over a. Then the product will be c over a. So what is our b? It is 11 over 5. And what's the product? Equals to 3 out of 5. So you have the sum is 11 over 5. And the product is 3 over 5. Remember, the equation is simply write down. Okay, write down the sums and the products of the roots of the following equations. So C and D will be used. This is C. C is 2x squared plus 5x is equal to 1. And the D is 2x into x plus 1 equals to x plus 7. Remember, they must be quadratic equations, and the quadratic equation is always equal to 0. So you modify your equation so that it is equal to 0, and then go ahead and find the sum and the product. Okay, let's look at another example about the roots of quadratic equations. Okay, example 2. Example 2. What is it? In our second example, they want us to write down equations, the sums and the products of whose roots are respectively. So the roots are 7. Oh, they want us to write down an equation whose sum is 7 and the product is 12. So in our solution, you have been given sum equals to 7. Then product is equal to 12. We said the most convenient way of writing this is to have your equation as we have x squared minus sum into x plus product equals to 0. That's the most convenient way of writing a quadratic equation if you are given the sum of roots and the product of roots. So this is going to be x squared minus 7x plus 12 equals to 0. And you have your equation. They have given the sum and the product, and simply write down the equation. You have it. Okay. So what is B? They want you to write down the equation if you have been given the sum as minus a half and the product is minus 3 over 8. Go ahead and write down that quadratic equation given the sum as minus a half and the product as 3 over 8. Let's do it just as simple. So you have been given sum equals to minus a half and then the product is equal to minus 3 over 8. So the equation is squared minus sum into x plus product equals to 0. So simply have x squared minus, okay, here you have minus a half into x plus the product, which is minus 3 over 8 is equal to 0. Yeah, you can multiply through by 8 and you have 8x squared plus 4x minus 3 equal to 0. This is the equation, okay? This is the equation whose sum of roots is minus a half and the product of roots is minus 3 over 8. Okay, let's look at some more. Yeah, some good problems. I think these are just obvious. Let's look at this. So here they are giving us a quadratic equation, which is x squared minus 5x is equal to 7. Actually, not a quadratic equation. How to arrange it to make it a quadratic equation. But they are saying that the roots of this equation is alpha and beta. And they want us to form equations whose roots are alpha squared, beta squared, or the base alpha cubed beta, and then alpha beta cubed. Okay, so we need to find the value of alpha plus beta, which is the sum of alpha plus beta. Okay, and also need the sum of alpha, the product of alpha and beta. Okay, to be able to form a new equation whose sum is alpha squared, beta squared, or b, which is alpha cubed beta, and then alpha beta cubed. So what do? The first step is to arrange the equation so that it is a quadratic. The next step is to get the sum and the product of the equation. Okay, so let's see the solution. So they have given us x squared minus 5x is equal to 7. You can write this as x squared minus 5x minus 7 equal to 0. It is now a quadratic equation because any quadratic equation must be equal to 0. So if you compare with the ax squared plus bx plus c equals to 0, then you discover your a equals to 1, b equal to minus 5, and then c is minus 7. But we discover that the sum, okay, of roots is alpha plus beta. This is minus b over a. And in this case, it's going to be minus of minus 5 divided by 1. So the sum, which is alpha plus beta, gives us a value just 5. Okay, negative is a positive. Then the product, okay, which we can call alpha beta, is simply c over a, and this is negative 7 over 1. This is minus 7. So we have alpha plus beta equals to 5. Alpha beta is minus 7. Okay, so we want equation whose roots are alpha squared and beta squared. Okay, we want to find the equation whose roots are alpha squared and beta squared, given the value of alpha plus beta and alpha beta. Can we form an equation whose roots are alpha squared and beta squared? From these two equations, one can go ahead and find the value of alpha and the value of beta, because we have two equations and they are two unknowns, so they can be solved simultaneously and get the value of alpha and beta. But that's a long way. If you go by that approach, it's going to be a long way. The easiest approach is to look at this expansion. Let's look at alpha plus beta squared. If you expand this, you end up with alpha squared plus 2 alpha beta, then plus beta squared. And it will mean that if you want to have alpha squared plus beta squared, this will be alpha plus beta squared minus 2 alpha beta. Why are we doing this? Okay, we have been given loops as alpha squared, then beta squared. We want the sum of loops. Okay, and this is going to be alpha squared plus beta squared. But we know the value of alpha squared plus beta squared. It is alpha plus beta squared minus 2 alpha beta. So instead of struggling to get the value of alpha, then the value of beta, then square, and find the value of alpha squared plus beta squared, this is just a shortcut. When you use this approach, this is a shortcut. You don't need to find the value of alpha and value of beta, so you can plug in and get the value of alpha squared plus beta squared. Okay, so from here, since we have it in terms of this expansion, then we can write this as alpha squared plus beta squared will be, or alpha plus beta is 5. So squared minus alpha beta, from this part we have alpha beta is minus 7. So what is 25 plus 14? I think we end up with 39. Okay, so we have the value of alpha squared plus beta squared, which is the sum of the equation we are looking for, the sum of roots of the equation we are looking for. Okay, what about product of roots? The product of roots is alpha squared times beta squared. These are numbers of different bases but same power. You can write it as alpha beta. Oh, sorry about my tablet is acting up, so I think I need to buy a better one, but it's okay. With time I'll get you one which is okay. So this is the alpha beta squared, and the value of alpha beta is minus 7. So if you square this, you end up with the 49. Now, how do we write the equation? So the equation is x squared minus sum into x plus product is equal to 0. And now this is x squared minus the sum is 39 times x plus our product is 49. This is equal to 0, and that's the equation whose roots are alpha squared, beta squared. Given alpha plus beta is 5, and then alpha beta is minus 7. So this is the new equation whose sum and the product. Okay, we have formed the new equation whose sum and the product is given. So part B of the equation, they have given us the roots as alpha cubed, beta, and then alpha beta cubed. So they want us to form a quadratic equation whose roots are alpha cubed, beta, and then alpha beta cubed. So let's go ahead and find the sum. Okay, when you get alpha cubed beta and you add it to alpha beta cubed, what do you get? Here is when we exploit our knowledge of factorization. This is alpha beta into alpha squared plus beta squared. Okay, and we said, or we found out that alpha plus beta was a minus 7, and then alpha squared plus beta squared from the previous question, we have this as a 39, not mistaken. Okay, so what do we get when we multiply negative 7 by 3? So you end up with negative 2, 7, 3. What about the product? Get alpha cubed beta and multiply by alpha beta cubed. This is alpha to the 4, then beta to the 4. And we can write this as alpha beta to the power 4. So what's this? Alpha beta is minus 7. If you power it 4, okay, it will give us, so the required equation is x squared minus sum into x plus product equals to 0. So this is x squared minus 273 into x plus 2401 will be equal to 0. And that's the quadratic equation whose sum is minus 273. And then the product is, actually the sum is a plus, okay? It is minus, so because the sum is a minus 273, okay? Then it's going to be x squared plus 273 x plus 2401 equals to 0. Okay, let us look at this example 4. I think it's going to be our last example here because we have seen so many examples. They have given us a quadratic equation, x squared plus 2px plus q equals to 0. And they are saying that the roots of that equation differ by 2. Now, how do we go about this? Let's look at the solution. So let alpha beta be the roots of x squared plus 2p x plus q equals to 0. So what is the sum? Alpha plus beta is minus b over a. And in this case, b equals to 2p. Okay, so this is minus 2p, and the a is equal to 1, so end up with minus 2p. Then the product, alpha times beta, will be c over a. And in this case, c equals to q. Okay, so we also been given some more information. I say that alpha minus beta, they differ by 2. Okay, now if I get alpha plus beta, which is equal to minus 2p, and we add these two, we get 2 alpha is equal to 2 minus 2p, and alpha is simply 1 minus p. Okay, so if we go ahead and have alpha minus beta is equal to a 2, and then alpha plus beta equals to minus 2p. So if we subtract, we end up with minus 2 beta as 2 plus 2p. And therefore, your beta is going to be minus into 1 plus p. So why do we go ahead and find the value of alpha and beta? Because it is easy. The second part, which said the roots differ by 2, is making it easy for us to find the value of alpha and beta. Maybe it is going to be so useful when we are trying to prove this expression that p squared minus q equals to 1. So we have two values. Alpha is equal to 1 minus p, and beta is equal to the negative of 1 plus p. Okay, let's go ahead and finish. So alpha 1 minus p, beta is equal to the negative 1 plus p. But we know that alpha beta is equal to q. Okay, so 1 minus p into 1 plus p, that is the negative, will give us q. So this is a difference of 2 squared. We have negative of 1 minus p squared is equal to q, or 1 minus p squared equals minus q. And I have 1 equals to p squared minus q. So in the end, we have p squared minus q equals to 1. And we have proved that they want us to. Okay, so next will be some trial questions for you. Okay, just practice to test your understanding of roots of quadratic equations. So these are some of the questions you can try out. Let me go ahead and give you more questions, maybe 2 or 3. You also need to read books, and a book like Backhouse 1, Pure Math by Backhouse 1 is going to be a very useful book. You can use Mathematics by Tranter. That's a nice book to use here. So you test your understanding. Don't forget to subscribe to my channel, and do not forget to hit the notification bell. That way, if I upload a new video, you'll be notified immediately. Okay? Yeah, I love you so much. Thank you for watching.